So folks, this is a review of what we covered on Friday. So let's do this problem. Some of you will look up here as you do it. Others of you will refer to your notes. And I'll be modeling it up here. But let's just jump right in. So I'm glad the handout's already on your desk. So let's do number one. So everybody should be doing this. And if you get stuck, you can, of course, look up here. But regardless, we should be attacking number one. So step one, name the test. And I'll try not to talk too much to allow those who are working the opportunity and the time and space to attack this. Bless you. Bless you. And again, if you get stuck / I do something up here that does not make sense, please let me know. So again, if you're good with this piece on the naming, then you can move to the conditions. So this is what we want to see under the name the test step. So let me see, are there any, yeah, Gertrude?
Is there only going to be a one sample for this?
Yeah. So anytime you're doing the goodness of fit, so comparing sort of data you have to what what we expect, it's always one sample. Today I'm going to talk about the kind of chi-square test you use in a different case. Good question. So now you go for the conditions. Yeah, so I'm doing the conditions right now, right? So we have 4 conditions, right? Random sampling, population is 10 times the sample, independent, and the last one, remember, was that the expected count was greater than 5. So we're saying each piece doesn't affect the other. right? So now we need to remember last time we figured out like what the expected amount per flavor is. You all should try to figure that out on your own. Remember, you want to add up the total number of cereal pieces. So the total. So here's how many pieces we have total, right? And there are 5 flavors, so we expect there to be 20% per flavor. Right. So you want to just sort of draw your table of the expected. So you just want to draw your table of expected counts. You might want to call this expected. And the flavors we have are grape, lemon, lime, orange, strawberry. So flavor, number, grape, lemon, lime, orange, and strawberry. Berry. Right, and this is my expected. And we expect 20% in each, because it said uniformly distributed. Eddie Paul? The fourth, right, so I'm about to show you the fourth picture right now. So give me 2 seconds. So we know there's a total of 2615. We expect 20% in each.
523.
So 523 in each. So the fourth condition says that each of these expected values is bigger than 5. That's all it says. Does that work, Eddie? So, okay, remember on Friday, Eddie, we looked at, so are you good at how I got these expected values? Do you agree with how we got these? Yeah. So I added up all the pieces in the cereal box, 2615. We divided by 5 to get the 523 each. And would you agree that all of these numbers are bigger than 5? That's the fourth condition. That all of these expected counts are above 5. So that's the conditions. Now you go to math. You go to the math step. What is it? Observed minus expected squared over expected. So now remember, you're gonna like write this out by hand, and then you'll let the calculator actually do the calculation. Remember, you need to write it by hand. So how many grape did we observe? 530 grape. We should have had 523. Plus lemon was 470. Should have had 523. Lime was 420, should have had 523. You can roll it over to the next line, no problem. Orange was 610. Tomorrow? Mm-hmm. Okay, because the other time they had given it to us in percents. Here they just told me that each category has the exact same amount. You see where it says uniformly distributed? So that means there's equal grape and lemon and lime and blah, blah, blah. So I just said, well, I know there are 2,615 total, so if I divide by 5, that's how much should be in each one. I basically just did a 20%, but that's another way of doing that is just dividing by 5. All right, and now you go to the calculator here. So maybe I should do it on a calculator that actually shows up on the board. All right, so remember you go into lists. So this was observed, so we called it O. Have a seat, Tex. You're fine, you're fine, you're fine. Have a seat. Have a seat.
Do it anyway.
So folks, you don't need to wait for me. Just like continue working. Stats, tests, chi-square, goodness of fit. Observed list was in O. Expected was in E. Degrees of freedom, remember you say how many categories minus 1. In this case, there'll be 4 degrees of freedom. Click OK. And here's your chi-squared, 47.5717. And your p-value, 1.1592 times 10 to the negative 9. Don't leave out the times 10 to the negative 9. That means it's super small. Brian.
How'd you get the 4 degrees?
One more time, I can't hear you.
How'd you get the 4 degrees of freedom?
So degrees of freedom are the number of categories. So how many categories? We had grape, lemon, lime, orange, strawberry, 5, minus 1. Draw the picture now. Label the degrees of freedom as equal to 4. Go ahead and draw the picture. Here's 47.572. Shade this in. Okay. The picture, the critical value, the p-value here, and then we write the sentence. Which one, Norma? P-value? 1.1592. 47.572. Or 5717. And then the sentence, right? Because the p-value, or since the p-value is less than alpha, we reject the null and conclude. What do we conclude? We conclude that the Trix flavors are not uniformly distributed. That's it. So let me write that down. So since p-value of 1.1592 times 10 to the negative 9 is less than 0.05, the alpha, we reject the null and conclude the Trix flavors are not distributed uniformly. And that sentence is step 4, the conclusion. Frida. Move the paper down? Yeah. So let me take any questions on this process, then I'm just going to show there are like 2 different ways to use chi-squared. We'll go through those. Eddie Paul.
How do we know how far to go?
always just a 3 spots, so I guess I could have stopped at 159. Here, that'll be fine. Does that make sense, Eddie? Good. Kendra question? No. What else? Great. Okay, let's keep going. All right. So, there are 2 other ways that we can use the chi-square test, and we want to talk about those 2 ways today. All right. So, some notes first, and then we will get into this. So, there are 2 other chi-squared tests, and the first one I want to talk about is chi-square test for association. And in parentheses, I'll put independence. This says independence in parentheses here. Okay. The chi-squared test for independence is used when comparing 2 categorical variables from the same population, and we want to test association. Now, association was a troubling concept before, so let me try to re-explain what we mean by association. Association just means this, that one variable seems to affect another variable. So let me give you an example. If I did a sample of people at Yes Prep, and I sampled middle schoolers and high schoolers, and asked their opinion of Selena Gomez, people in middle school will likely have a much higher opinion of Selena Gomez. So we would say that being in middle school or your age is associated with your opinion of Selena Gomez. Put differently, if you did a survey of Indian people and non-Indian people and asked, do you like Indian food? We would imagine people who are Indian are more likely to say yes. So we would say your ethnicity is associated with whether you like Indian food or not. Associated means if one variable seems to have some effect on another. Not necessarily that being Indian causes you to like Indian food, maybe it does, but that being Indian is associated with being more or less likely to like Indian food. It's not that being in middle school causes you to like Selena Gomez. It's that being in middle school is associated with being more likely to like Selena Gomez than you all are. That's what I mean by associated. Other questions on that? I try to give a concrete example. Okay, so what are the conditions? Well, let me not be too suspenseful here. The conditions are random sampling. The conditions are population 10 times the sample size. Expected counts are greater than or equal to 5. And the fourth one, we already really hit it up here, but the fourth one is that we have categorical variables. So if you already state that you have categorical variables up here in the naming the test, you don't need to restate it down here. You can if you want to, I'm not going to count off. categorical variables.
I'm finding for number 3, you said it's greater than the 5, so it's greater than or greater.
Greater than or equal to 5 is fine. Good question. Greater than or equal to. The null hypothesis is always variable A and variable B are not associated. And again, we're about to do an example that will sort of flesh this out a little bit. Yeah. Number 3 says the expected counts are greater than or equal to 5, so the same as before. Variable A and B are not associated, and the alternative is they are associated. All right. So the degrees of freedom here, because there are now 2 variables, not just one, degrees of freedom are equal to, and let me write this first and then I'll show an example. R minus 1 times C minus 1, where R stands for rows and C stands for columns. And I'll show you what this looks like by way of an example. You need to get your charger out? Okay. Yeah, no problem. Hold up. Does that work? Are you able to get it? Okay, and the expected counts, let's get the formulas down, then we'll do an example, is n from the row times n from the column divided by n total. And again, example will flesh this out. Come on. EC maybe? I never seen one though. Okay, so now let's just pick up here and apply it to example number 2 on the sheet. Okay, so we have a rural county hospital that offers health services. The hospital administration conducted a poll to determine residents' satisfaction with the services depended on gender. Okay, a random sample of 1,000 residents in the county. So the county population is the population we care about. The gender was recorded, and each was asked whether he or she was satisfied with the services offered by the hospital. The data are shown in the table below. Using a significance level of 0.05, conduct a test to determine if, for adult residents, there is an association between gender and whether they're satisfied. Okay. Anytime they're asking about association, we have to use this test. Anytime they're asking about association of a categorical variable, we use this test. So we're going to say chi-squared. This would be like name of the test. And you can either write for association or you can write for independence. Doesn't matter. Okay? And you're going to say, because we are checking if 2 categorical variables are associated. So we're checking if 2 categorical variables are associated. Smart? One more time. Yeah, it's the exact same one. So we'll write it for this example when we get there. But it's the exact same one. Checking if two categorical variables are associated. And you might want to write over here that the categorical variables are gender and satisfaction. Satisfaction is the other categorical variable along with gender that we're testing. Okay, now we write the null and alternative just like before. So the null is gender, that's variable A, and level of satisfaction. Satisfaction are not associated. And the alternative, gender and level of satisfaction are associated. Gender and level of satisfaction are associated. So that's step one. That's naming the test. We name the test and we put the hypotheses. Next step is conditions. The conditions are, as we said earlier, random sampling, which they told us. So conditions, random sampling is stated. We assume the population is 10 times the sample size, is 10 times sample size. So sample was 1,000, so we assume there's more than 10,000 people. 10,000 plus citizens in the county. We already talked about, we had categorical variables. We talked about that up here. We don't need to restate it. And expected count, and we're going to prove this in a second. Expected counts are greater than or equal to 5. Okay. And then you might say, see below for the table. And you're going to do this in a table here in a sec. You might just tell them, hey, I'm going to show you this in a table. I know this is a condition. I'm going to prove it to you in a table. Okay. So now we go into like a little bit of a new piece, which is how do we calculate these expected counts? So take a look at the table you have here. Satisfied, not satisfied, male, female. So let me kind of pull this up here. Okay. So this is, if you want to write here, this is the observed. This is what we observed. The expected is calculated in the following way, and this is crucial, folks. Here's how you calculate the expected. The expected for this box right here. So if I drew another table here, so this box right here, male and satisfied. The expected is the following. You look at the total from the column, 464, times the total from the row, divided by the grand total. So you take the total from the column, times the total from the row, divided by the grand total. So this would be 464 times 800 divided by 1,000. Okay, 464. Question, yeah?
Okay, so what you just did was you did all the males and you did times the satisfied, and then you did divided by 1,000?
I did all the males, because that's the column, times all the satisfieds divided by the grand total. So row total times column total divided by this. sometimes they won't give you the totals. You'll have to find the totals on your own. So which would just be add these up. Okay. Are there any questions on how to do expected counts? Okay, here's the key. We're in very good luck. We don't actually have to do the expected by hand. The calculator will do it for you. You don't have to do it by hand. I just want to show you, because on multiple choice, they may ask you, how do I find the expected for this? So now we know. Row times column divided by total. Okay, let's let the calculator do the work. So, let's go to the calculator and see how to plug this in. This will involve a new set of steps, and it will involve something you have never seen in your life before, called a matrix. This is a topic I wish we got to in pre-cal, but you guys know my thoughts on the curriculum in pre-cal, so let me not belabor the point. So, on Inspire first, you're at the home screen. Okay? Right? Do you guys have the calculator notes sheet? That would be good to have. If not, look on, or you can just write down what I say. Okay, you go menu, matrix vector, here we go. Matrix vector. Again, let's start with this, and you want to say create. And you want to create a matrix. Okay. Let's start with Inspire first. Okay. Now they want to know, this is called a matrix right here. They want to know how many rows and columns are in the matrix. So I have 2 rows, right? The total is not a row. Like the total is just something that was calculated to make our life easy. That's not a row. The row are, what are the different options? Well, there's satisfied and not satisfied. Only 2 options. So rows are 2, and columns, either you are male or you are female. 2 and 2. We click OK. Okay. Any questions so far? I'm deliberately going slow because I'm very new. Okay. Now just plug in what is in each spot. So this is 384. This is 416. This is 80. This is 120. Do not put the totals in. Do not put the totals in. Okay. And then click enter. So everybody on the Inspire should have the matrix here on the right side. Now we click store. This is the key, folks. You go Control var to get it to store. And just click A. It's fine. Or A or observe. You can put it as O. I'll put it as O, in fact. Yeah.
What's a var?
VAR right here? Above the 9?
Oh, var.
What did I say?
I did say a var.
So you store it as A or O, or pick any letter you want to call it. You can pick any letter you want. I just picked A. Okay? Folks, here we go. Now, here comes the next step, folks. We go menu, menu, statistics, number 6, stat tests, number 7, and you do number 8, chi-squared two-way test. Two-way means the 2 separate. Click enter. Okay, observed matrix is called, notice how if you just click the arrow that this A comes up automatically. Just click enter. Okay, click OK. And there we have it. Everything done for us. Okay? This, folks, this right here is the chi-squared, 4.117. This is the p-value. This is the degrees of freedom. Please note that down. 83, 84, folks. Here we go. 83, 84, you come in here, you go second matrix, which is the x inverse, right here. And the matrix screen pops up.